All right, see how this works? See if I get anybody on here. Okay. All right. Do you have any questions you want to look at this morning?
Was it on page 193, question 2A?
Okay, page 193.
Yeah.
Okay. Question what?
2A.
Okay, so I've got the cube root of b to the fourth y. Yeah. Okay. So, and it wants us to write each entire radical as a mixed radical. All right. So can I break down the y?
No.
Okay, look at it like this. If I have the square root of 5, can I break that down? Like, do you know what I mean? Like, okay, if it's not a perfect square, I can't do anything with it. If it's going to give me a decimal, I can't do anything with it. So I can't do anything. It stays as root 5. The square root of 8, on the other hand, I can find a perfect square that goes into it. All right, so I can change this to root 4 times root 2. Now, root 2 can't be broken down anymore, but the square root of 4 can. So that's 2 root 2. Right? Okay, so when I go back to here, y can't be broken down. So I'm going to divide this, I'm going to separate these into 2 parts. Like this. Okay? And then this guy, I'm going to find out how many b cubes I have in this. Well, I have 1 b cubed for sure, and then I have b left over, right? You follow so far? And then this is cube y like that. All right? Okay, so then what's the cube root of b cubed?
B.
Just b. And then what am I left with? B times y. Okay?
And that's the answer.
That's it. That's the answer. This is considered a mixed radical because I have my coefficient and then I have my radicand. All right? So that's what a mixed radical is. I don't have many on here yet live, so we can keep working if you want. Okay, so this is going from an entire to a mixed. To go that way, all right, to go from 2 root 2 to root 8, because it's a rooted value, I root the coefficient and I also square it. Okay, because the square root and the squared value, they cancel themselves out, right? So I've got 4 times 2. This works out to root 8. So this is going from a mixed to an entire radical. And so that's all you're doing in this lesson is flip-flopping back and forth.
And then if it's like a cube root, you cube it?
Yeah, that's right. Yeah. Yeah. So if I had 2 cube root 3, let's say, okay, I would go cube root 2 cubed times cube root 3, like that. And that would give me cube root 24, 2 cubed. All right? Good. You have any questions? Did you look at yesterday's lesson? You haven't looked at it yet today? Okay. All right. Well, you should start back at the page 1, 89. Okay, so what we're working with is radicals. All right, we did this in grade 10. Okay, this is a coefficient. This is called a radicand. That's the radical sign, and that's the index.
This
All right.
was one of my favorite things to do last year.
Yeah? Okay, so we started yesterday with 5 root 3. And we have to change it to a entire radical. So I can't multiply a coefficient times a rooted value. So what I want to do then is I want to change that to a rooted value. To do that, I basically do opposites or inverses, whatever you want to call it. Okay? So if I square root it, and I square it, that's just the same as 5. All I'm doing is changing the form of it. So the square root, so 5 squared is 25. 25 times 3 is 75. You remember this? Yeah, you do? Okay. And then if you flip over, going the other way, if I have a square root that isn't a perfect square, I take the square root of 192, and I find a perfect square that goes into it. So square root 64 times square root 3. Square root of 64 is 8. 8 root 3. So the one thing that you do want to do is you want to write out, you want to know all your perfect squares. That will make life a little bit simpler when you're trying to break them down. 6, 7, 8, oops, missed one. 21, 144, and even up to 13 squared is 169. So you want to make sure that you know those values because it makes doing this a whole lot simpler. Same with the cubes. You want to know your first bunch of cubes as well. Okay?
For B on page 190.
Yep.
Because it has,
Okay, so that's,
the power center.
sorry,
Like, because, it has like,
7x squared?
yeah,
You're on B, aren't you?
cube root of y semester.
Mm-hmm.
For this, like, 7, what would you have like?
You just leave it.
Oh.
You leave everything underneath there. All you're changing in that case is this. You got to cube the value in front. Okay? And once you cube that, then from there you can go, from there, you multiply whatever this is, so that's minus 64x cubed, you would times it by 7x squared. And then it would all be under the cube root part.
Like, she's talking about a different question.
Or are you? Which one are you talking about?
On the next page, 190.
Oh, my bad. Oh, I see. Sorry. Okay, now I understand. Okay. Okay. So, why to the 7 like this?
Yeah.
Okay, because I have variables. All right, now, when I do this, the cube root is 16. I need to find out how many perfect cubes go into here, or what the highest perfect cube is that goes into it. All right, so 8 goes into it. So basically what I'm doing is I'm breaking this down so that when I take the cube, I can break it down like this. I can go y cubed times y cubed times y, like that. The cube root of y cubed is just y. Cube root of this y cubed is also just y, and I can't do anything with that. It stays like this. Okay? And then I multiply those two, which gives me y squared. Like that. Okay? You all right? Yeah? Okay, I'm just going to check. Keep checking emails to make sure that I don't have any questions. Okay. Morning, anybody watching live? You can type a question into the question box, or the comment box, sorry. So if you have a question you want to watch today, type it in. Oh, Austin Cowan. Okay, page 198, number 15. Okay. Okay, use the relationship between the sides of a 45, 45, 90 triangle to show that the area of an isosceles triangle can be found using the formula A equals s squared over 4, where s is the length of the hypotenuse and A is the area in units. Okay.
For that one, would you use like close time to like figure out the side and then plug it into the equation?
Well, okay. Use the relationship between the sides. All right, now, a 45, 45 triangle. So this goes back to, I just want to make sure I'm certain we went through this already with our special triangles. Okay, so this kind of goes back to 2.2 when we started looking at the unit circle and we looked at special triangles. Okay, so I'm going to write this out right now, Austin. We're going to do Okay, I'm going to use this to explain it. So 45, 45, that means that this and this are the same right here. So those two values are the same, right? So that means that if I have x squared plus x squared equals 1 squared, right? So therefore, 2x squared is equal to 1. X squared is equal to 1/2. X is equal to the square root of 1 over 2, which is 1 over square root 2. And we haven't got into this yet, but we got to, if we rationalize this. So that means that the length of one of those sides is root 2 over 2. So if it's root 2 over 2, okay, and this is going to look small for a second. I'll draw it as big as I can here. So then looking at the triangle they give us, in which this is S, this would be root 2 over 2 here, and this would be root 2 over 2 here. Okay, so there would be, just a second now, the area is equal to S squared over 4, where S is the length of the hypotenuse A, and A is the area in the square units. All right, so if I was looking for the area of this, I feel like I don't need to do it this way. Because the area of this would be 1/2 root 2 over 2. No, scratch this. I don't like the way that this is set up. It must be using S in a different way. So let's try this again. Draw it out again. 45 degrees. 45 degrees. Okay. So this is my height, this is my base, this is S. All right. I think this is what we wanted to do. Okay. I know these two are equal because we just did that, and they're across from the 45 degrees. So I've got x squared plus x squared is equal to s squared, right? Okay, and my area is 1/2. Sorry, I made this way more complicated than I need to. 2x squared is equal to s squared. All right, this is 1/2 x times x, like that. Okay, now if I solve for x squared here, I'm going to get x squared is equal to s squared over 2. Okay, therefore x would be equal to s over square root 2. So the square root of s squared is s. The square root of root 2 is root 2, is what x is equal to. You follow me here? Yeah. It's a little confusing. I'll go back and I'll explain this a little bit better because I don't like the way I did this. But anyways, so here's how it works. Now I've got s over root 2 times s over root 2, like that. All right, a little more complicated question. So square root 2 times square root 2 is just 2, right? 2 times 2 is, so if I multiply across the top, I get s squared. And if I multiply across the bottom, I get 2 root 2 times root 2 is the same as 2 times 2, which is 4. And that's how I get my area. Okay, so I made this a lot more complicated than I needed to. So let me go back through it and do it again. Okay. So let's start from the beginning. All right, starting from the beginning, this is x and this is x. And the area is equal to 1/2 x times x. All right, base times height is the area of a triangle, right? 1/2 times base times height. Okay, so I want to work with the s because that's all I really know. So I know using Pythagorean theorem, I've got x squared plus x squared equals s squared. So 2x squared is equal to s squared, right? Follow me so far? So I got x squared plus x squared is 2x squared equals s squared. Then I go x squared is equal to s squared over 2. Okay? And so I want to find out what x is equal to because I need to substitute in here. That's my goal. So I take the square root of these values and I end up with s over square root 2 is equal to x. Okay? So that first part where I was doing the root 2 over 2 stuff, that's essentially what this is. This is 1 over root 2 and this is 1 over root 2 when it's 45, 45, 90. Okay? So now I substitute it in. I've got 1/2 s over square root 2 times s over square root 2. Like that. Okay? There's not a lot of radical. I suppose there's a little bit of radical work there, but multiplying across the top and multiplying across the bottom, and that's where I end up with right there. Okay? All right. Any other questions in here? You okay? Any other questions?
On page 193 to C, the x cubed is like confusing me because I don't know where to place the movement.
Okay, so here's the thing. When you're breaking them down, I like to break them down individually and then put them back together. Now you can do it whatever way you like, but this is my own preference. So I'm going to go cube root negative 48 times cube root, is it x cubed?
Yeah, and then y.
And then cube root of y. Now, just looking at this, I can't do anything with that. That's going to stay in the rooted value. All right? This guy, I see 48, and as soon as I see 48, I'm saying to myself, I think there's a perfect cube that goes into it. All right? So what's the largest perfect cube that can divide into 48 evenly? Look at your list of cubes that you wrote down. Which one of them divides into 48?
8.
8 does. And what do you times 8 by to get 48? That's 6. That's right. Okay, so here's how this works. I go cube root 8 times cube root negative 6. I'm going to leave the negative on the 6 part. I don't have to, but I'm going to. And I have x cubed, and then I have cube root of y. All right, what is the cube root of 8?
2.
What's the cube root of x cubed?
X.
And these other two, I can't break them down, so I leave them like that. So your solution is that. Okay? Excuse me. So the easiest way to do that is to split these values up. All right? Page 194, number 4. Okay. Okay, state a radical expression that would form a like radical pair for each expression. Okay, so basically what you're doing is you're taking a entire radical or whole radical and changing it to mixed or a mixed radical and then changing it to a whole. So for the first one, square root 28, I'm looking for a perfect square that goes into 28. That being 4. Okay. So then that works out to 2 square root 7. So that's a similar radical or a like radical. So root 28 and 2 root 7, are like radicals. So now I can work the other way with the second one, 7 cube root 2. Okay, so I can't multiply a coefficient times a rooted value. So I need to go cube root of 7 cubed, like that, okay, times the cube root of 2 equals, all right, so whatever 7 cubed is, okay, math isn't good this morning, so what is that, 49 times 7, 28, so that's 63, 28, 343, I think, and then 343, so that's cube root of 343 times the cube root of 2 equals the cube root of 686. So you would consider that a like radical. So that's all that number 4 is doing, is working both ways as far as I can see. Yeah. And it even says that for parts D, E, and F, what do you need to do before you and cube rooting it at the same time, or squaring it and square rooting it at the same time to get that. Okay. All right. Any other questions? You're okay so far? Yeah? So on Monday, I will teach 5-2. So part of your 45 minutes or whatever, how long I need to, I'll teach 5-2, and then you can follow on there and then ask questions through the comments there. Well, bless you. One person checked in so far this morning.